All right, so now here's another one. We're just going through these examples, three different examples. This is the third one. So it says, before a winter storm, a pile of road salt has the dimensions shown. Clearly, we don't really get storms like this, but in bigger, like places that have more extreme weather, they use road salt. If you guys didn't know that, but it says, after the storm, the linear dimensions of the pile are 1/2 the original dimensions. How does this affect the volume of the pile? That's A. We're going to start with that, and then we'll move to B once we cover A. So first off, you can see that it's a cone. Hopefully you can see it's a cone. And then when you look at this, we're going to say we need to first off find the height of the cone, because we know the slant, and if we drew, we drew a line down from the top to the base, we'd be able to use the radius, the slant height, and then we would need to solve for the regular height using the Pythagorean theorem. So that is our first step, because we need that in order to find our volume. So let me make this smaller so I have more work. There we go. All right, so first up, we need to do the Pythagorean theorem. So our radius, if the diameter is 90, our radius is 45. So this is 45 squared plus, we don't know our height, height squared equals 53 squared. That slanted piece is our hypotenuse. So when we solve it out, we get 2025 plus h squared equals 2809. Move over that 2025. You get 784 equals h squared. Take the square root. You're only going to be looking at the positives because we are looking at an actual distance. And 28 equals our height. Now that we know the height for our problem, we can go ahead and we can find the volume. What we are doing for this problem is we are comparing the volume, and then we are comparing the volume after the winter storm when our dimensions are half. We want to see how the volume of the pile is affected. So I'm going to go ahead and let's do a little table. This is before, this is after. We're going shorthand here. So before, our radius is 45 and our height is 28. After, our radius is 22.5 and our height is 14. Right? We cut both of those in half. So the volume is 1/3 pi r squared times height. 1/3 pi times our radius squared, 45 squared, times 28, which is our height. Leave the pi for last. What I recommend doing it in your calculator so you get the best answer, do 45 squared, multiply it by 28, then instead of saying times 1/3, just divide it by 3. That's the same piece, and then put pi through if you want to. I'm going to do it leaving pi out because we are just comparing the two, and they're both going to have pi. So when I plug everything in except for the pi, I'm going to get 18,900 pi, and that's feet cubed. I ran out of room. All right, so that's the first one. Now the second one, literally all we have to do is use the volume formula again with our new dimensions, which are half. So 1/3 pi times 22.5 squared times 14. That is going to give us approximately, it's not going to be a whole number this time, 2,362.5 pi feet cubed. So we have our two volumes. That's volume after, volume before. I'll just give a B and an A with both of them. We need to compare them. So let's go ahead and say our ending, which was 2362.5 pi over 18,900 pi. The pi's cancel out, And when you look at this, you get 1/8, reducing it. You could also get a decimal and then figure out what that decimal is. But it is 1/8 the size of the original volume. All right, so it's 1/8 the size after the storm. So that actually takes out quite a bit of volume on it. That is A. Now we're going to go ahead and we're going to look at B. Now B says a lane mile is an area of pavement that is 1 mile long and 1 lane wide. During the storm, about 400 pounds of road salt was used for every lane mile. We need to estimate the number of lane miles that were covered during the storm. A cubic foot of road salt weighs about 80 pounds. So before we get into anything, we want to look at how much salt was used during the storm. So we have our before, which is 18,900 pi, and we have our after. So let's go ahead, subtract those to find out how much cubic feet was used. So I'm going to go ahead and I just need to bump that out of the way. I'll rewrite it just because I'm running out of room. So before our storm, we had 18,900 pi. Then at the end of the storm, we had 2362.5 pi. So in total, the amount that was used was 16,537.5 pi cubic feet, or feet cubed. That's how much was used. That's the volume of it. So now we need to use conversions to see the number of lane miles covered with road salt. So starting off, pounds of road salt that was used. We need to change this from feet into pounds. It says that a cubic foot of that road salt weighs about 80 pounds. So we need to go ahead, do conversions, and we're going to set it up so that we look at how much road salt we used times 80 pounds over 1 foot. So that's 16,537.5 pi. That's feet used, and then we're changing that. 80 pounds is in 1 foot. The feet cancel, you multiply across, and you get 1,323,000 pi pounds. Okay, that's how much salt was used. Now we want to look at those pounds used and then cross that over into the lane miles. So it states that there are 400 pounds of road salt for every lane mile. You guys can do a large problem. I find it a little easier breaking it up. But in pounds, we've got 1,323,000 pounds used, and it's saying 1 lane mile uses 400 pounds. The pounds now cancel, and you are in miles, which is what you need to be. When you multiply that through, you get 10,390.82 lane miles. So we can obviously round that to approximately 10,391 lane miles were covered by that amount of salt. So I separated it. You guys, if you can follow along with it, you can set it into one big dimensional analysis problem. Like if you have taken chemistry, I know you have used, it can be a long piece across. So you could have done the feet and the pounds and then into lane miles over pounds together. The pounds would still cancel. Now, if you need to split it into two, similar to how I did, that's totally fine. Just do what works best for you. And this is the last example. And there's only about 5 problems because these do take a little bit longer.